In this video, I want to look at problem 49 from our textbook. You should stop the video and read this problem carefully and copy it into your notes. What we're being asked to do here is assume that we have a set M that has an accumulation point, and we're being asked to show that M has at least 2 points, and then we're being asked to figure out whether or not M has at least 3 points. So to get started on this problem, we have to actually go back and remember what the definition of an accumulation point is. So let's let M be a set, and let X be an accumulation point for set M. Now what that means is that for every open interval called O that contains X, there exists a little m inside capital M such that little m belongs to O and little m is not equal to X. And we have to use this definition to ensure that X has at least 2 elements, and then we have to figure out whether or not this definition says M contains at least 3 elements. So what I want to do is I want to actually get started by looking at a picture. So we're going to draw a number line. And I want kind of a big number line. And what I'm going to do is I'm going to put X somewhere on this number line. Now I'm going to pick a big delta ball centered at X. So here is my first big delta ball. Now a delta ball, of course, is an open interval and it contains X. So because X is an accumulation point, there exists an M1, I'm going to call it, inside set M, such that M1, let's clean up my notation there, such that M1 is inside this delta ball and M1 is not equal to X. So I'm actually going to put in a point somewhere. This is going to be M1. Now, because M1 is not equal to X, there is space between X and M1. And because there's space between X and M1, I am going to be able to say there exists a delta ball centered at X, and I'm going to call its radius delta 2, such that M1 is not inside that delta ball. I can draw one. So this is my second delta ball. And clearly M1 is not inside that delta ball. But this is still an open interval containing X. And since X is an accumulation point for set M, there exists an M2 inside M such that M2 is inside this new delta ball and M2 is not equal to X. So M2 is somewhere in here. Let's put M2 over here. And clearly, because M2 is inside this smaller delta ball and M1 is not, we can make the note that M1 and M2 are clearly different elements, and they are both inside set M, and consequently set M has at least 2 elements. Well, we can repeat this argument to get the third element. So let's see. Again, since M2 is not equal to X, there's space in here, and we can say the following. Since M2 is not equal to X, there exists a delta ball centered at X such that M2 is not inside that delta ball. And you'll notice that I've called the radius of this delta ball delta 3. So this delta ball would look something like this. But X is an accumulation point for set M. So there exists an M3 inside set M such that M3 is inside this new delta ball, and M3 is not equal to X. So M3 is somewhere in here. Maybe M3 is right there. But again, what I want to notice is from that picture, we know that M3 cannot be equal to M2, and M3 cannot be equal to M1, since M1 and M2 do not belong to this smaller delta ball. And hence, set M contains at least 3 points, namely M1, M2, and M3. In the next video, we're going to continue investigating this idea and where it goes in its natural conclusion.